Okay, talking about, I jumped ahead, talking about NTP. This is Network Time Protocol, and I went to some extra effort on this because NTP isn't specific to Linux. It's going to be for anything that you want to do. Knowing that you've got the right time on the server is worth a lot. Why is time synchronization important? Why is it important that my server has the exact right time up to some point? Computer hardware clocks are susceptible to drift, and that's your term. If you set your time however you want to do it and then come back a week later, that hardware clock will have drifted some amount. Now you could imagine a few seconds it may have drifted. If the battery is slow, it could have drifted further. In the US, our frequency of our power stays right at 60 cycles, doesn't it? You get the 60 cycle hum, but that's one good thing about the US. That's very, very constant. Your voltage may go up and down, but the hertz of your line is going to be very consistent, and that's one of the things that your hardware clock, that will affect your hardware clock. But anyway, your hardware clock still can drift. So transaction times between computers can be off. Think about bank transactions. Now obviously the larger the difference, the more it's going to matter, but if it just happens to be which came first, this one or this one, could make the difference of was your account funded when we wrote this check or wasn't it? Did you just bounce a check or did you not? Emails, which happened first? That's some simple stuff. How about a Kerberos token? If you were issued a token on one machine and go to another machine to access a resource, and your token has a timestamp that's in the future, that could be screwed up. Real-time systems, I'll throw another one in here. Real-time systems could be very affected by it. What if you have robots that are working an assembly line or something other, and something has to happen every half second, and then you got another one that something has to happen every half second? So those would be real-time systems. Could make troubleshooting harder. When came what? And again, you have to make the decision here about how close is good enough. Horseshoes and hand grenades, by legend, are actually pretty forgiving. Other things may not be. So what I'm saying here is if you're running an email server or some kind of banking server, you're going to want your time to be tight, really tight. If it's just a workstation that some guy does documents or draws with CAD or a million other things, maybe setting the time once a day, just keeping it in time may be good enough. But that's just something for you to decide. NTP uses UDP Port 123. Kind of easy to remember. It's not the kind of thing that makes a solid connection, transfers, breaks the connection. It's more of a DNS kind of thing that just kind of, here you go, here's you some information, catch the ones you can, and that's the way it works. Can monitor several upstream time sources, which is cool because time servers can go crazy, or if you have 3 different ones, it'll pick 3 by default. I've been putting in 3 by default, and if one of them seems kind of crazy, it can check them against the others just for a reference to see if one of them is pretty far off. Can pair with other local time servers for additional accuracy. So you're just asking more people the same thing. If you want to know what time it is, I can ask Philip, and he may tell me one time. He may be lying, his watch may be off, whatever. But if I asked everybody in the room what time it is, I could start to build an average and say it's probably right here in this range because more people said this than said that. Same sort of deal. You can use cryptographic keys to prevent the man-in-the-middle attacks. You can go to the extreme of putting passwords on both ends to say, okay, here, this is encrypted so nobody can monkey with it. By default, though, you filter it pretty good. You can filter it with IP tables if you want to. It's hard enough to where it's a decision for you to make if you wanted to really go to the effort to do cryptography on this. And again, I give you the classic example of why would somebody want to do that. One of the classic hacks was the guy that broke into AT&T and flipped the clock 12 hours so that in the middle of the day, if you called your grandmother in Omaha, you were getting 12 o'clock at night rates instead of 12 o'clock at day rates, which basically just made a mess for AT&T, and he proved he could do it, but there are things that could screw up. Your errors by default are sent to var log messages. Errors, updates, all that stuff. It is a very old protocol used by lots and lots and lots of servers out there. It was one of the first protocols. One of my big questions when I started fooling with this is like, how accurate is it really going to be when you got to figure in network time and all this other stuff? It's complicated. There's a lot that goes into it that, you know, we're just going to do the basics. But you can achieve under 50 milliseconds over a WAN. Sometimes it'll be greater, sometimes it'll be less. It will vary.
Wouldn't it be part of the algorithm? Like when it gets to its destination, it figures how long it's been.
It can. There's algorithms that work with it.
And then if it does that time lock or whatever.
It can. That's what it does. It figures it off of its sources. Need to give you a new word, stratum. Stratum is your distance to your real live clock. Stratum 0 would be a device. Notice I'm not saying a computer, because it can't be a computer. It is a device that uses something like GPS or an atomic clock or something like that to calculate the exact time. Naval stations have always been places that have always been, it's been very, very important to them to keep exact time. And if you watch the History Channel and learn how they did longitude and latitude, it was very important to have the correct time while you're out there on your ship being blown around by the wind. If you didn't have GPS, you looked at the stars, and depending on what time at night, you could use your sextant and figure out where you were by saying, okay, where is this star and what time is it? You could figure where you were in the ocean. So that's why the Navy was always very, very interested on exactly what time it is. Stratum 1 is a device that is attached to that. You buy a computer that has an accurate time card in it, and you have a Stratum 1 device. The only delay that you would have would be over your bus. Stratum 2 is a computer that gets its time from Stratum 1. So you're going to have the delay over a network to get to your Stratum 1. Stratum 3 is going to get its time from the Stratum 2, and Stratum 2 is going to get his from Stratum 1, and Stratum 1 is going to get his from 0. You're seeing the chain of stuff. Stratum will go on up. You'll see Stratum 15, 16, 17. If your computer uses itself and makes up its time and just pretends, which it will do, certain applications need that, it considers itself Stratum 10, which means if anybody else tells you what time it is, they're probably more correct than you are, so it would take it. Stratum is a measure of distance from the clock. It is not necessarily an indication of reliability or quality. To read my own PowerPoint. You can be attached to a Stratum 4 server and be more accurate than something attached to a Stratum 1 if the Stratum 1 is off. So it's not a guarantee that your time is going to be better, but that's your idea. Time servers. There are lots of time servers out there that you can attach to for free. You have, this is another term that you see, primary is your Stratum 1 servers. Normally, just to be nice, you don't want to just go and pick you out a Stratum 1 server and attach to it over the internet. If it's open to the internet, it can be overwhelmed by everybody attaching to it. Again, you go back to what are your needs. If you've just got a basic server, if I can achieve 50 millisecond accuracy by hitting a Stratum 3, that's good enough. You know, in most cases, it's what it's going to be. You don't have to be freaked out and say, oh, I have to have a Stratum 1. Kind of like you don't have to have the absolute bleeding edge last release of the kernel unless you have some specific need. There's no sense in killing yourself, and no sense in overwhelming your primary servers. Stratum 2, they're used a good bit. Stratum 3, really common. And I put this in here, and in practice I found out that just in picking pools of servers of people that had elected to become part of a pool of servers, there were some Stratum 1s in there. And I figure, well, heck, if they said they wanted to be in the pool, then you can use them. And there's that term. A time server pool is somebody has a time server and they elect to be a part of a pool, and they say, there you go, use my time server. And it will become a part of a pool, and you will select 3 out of that pool, or select 1 out of that pool. And to keep things down, they just do a balanced round robin through all of them. You can get a list of your time servers and pools from ntp.org. That's kind of like just your basic site. Do what? I'll give you the PDF when we get done. The NTP files. You have etsy ntp.conf. That's your main guy. That's what we're going to be editing with. You have etsy NTP keys, which are your cryptographic keys. Step tickers. Red Hat liked you to edit your step tickers to put servers into instead of actually editing your ntp.conf. The way it works is step tickers will send out just update me, just real quick. And then it would go into your algorithms for your NTP and move. So the step ticker is just used just at the beginning. And you can look at the scripts and see how they do it. And that's what they're doing. There's a file called etsy NTP Servers. And you actually have a little application in CentOS Red Hat system config time. Now that's going to be very, very Red Hatty, CentOS-y. If you go to a Debian system, I wouldn't expect to see it there. But that is just a little GUI that helps you configure your time. Okay, I stepped back just for a second to catch some people up, but I noticed I left this last line out. Some organizations purchase their own time hardware. Again, computer science changes frantically, is the adjective I like to, or adverb I like to use. But these days you can buy your own time hardware. The college here has their own time hardware that uses GPS, which would make us our very own Stratum 0, Stratum 1 server right here on campus, which we could use our own, and that's cool. But for under $2,000 or $3,000, I think you can pick up a pretty high quality device that will keep accurate time for you, and then you're not dependent to reach out across the internet for anybody. And I think that's becoming more common. Configuration options in ntp.conf. You specify your servers or pools of servers. And by default, CentOS gives you server 0, server 1, server 2, CentOS pool ntp.org. So CentOS has actually gone out and created their own pools of people that wanted to be member servers of it. And I also threw in an example of just a single server. You can use an option prefer to say, I like this server, prefer it. Now that does not mean use it all the time. If you wanted to use it all the time, you'd take the others out. But the others are obviously still in there. And what will happen is it will prefer that as long as your response time doesn't get to be too long. If your response time goes completely south, it will have enough sense to say, I know you preferred it, but it's dying. We're going to switch over to one of the others. You will have one primary that you're going to receive time from. You'll have a primary, and then you'll have some candidates. That would be your primary. And if it died, it would jump to one of the other candidates, depending on which had the lowest delay. You have an option called restrict. This is your filtering. The way you would actually do this would be, this is the same that was on the last page. You specify your servers, then you say restrict this guy, Netmask of 255, 255, 255, 255, which means specifically that server. You can specify it. That keeps your man in the middle down. If somebody pops in with 192, 168, 199, he's going to get ignored, depending on your ignore option. You can say what they can do and what they can't do. You're saying, let these guys through, but he doesn't get to query me. He doesn't get to send some kind of funky command to modify what my time is. I'm just asking him what the time is, and I'll modify it myself. You have a lot of different options there for the end, and they get kind of complicated. There we go. That's basically what I said. Query, deny queries, deny attempts to modify the time using some kind of funky command, and can't trap to try to become a peer to try to modify your time. This is all just stuff to keep somebody from jacking with your time. Okay, your commands. One of your big ones is going to be NTPQ, and the way you use it, NTPQ space -P, and you're querying your time servers. What I'm showing you right here is just one of the ones that it picked out. The star right here represents your current preference, which one it's actually using. If there's a plus sign right there, that means yes, I'm getting stuff from them, but they're just there as backups in case the first one fails. The next one is the remote name for who you're pulling your time from. Then your ref ID is who is he pulling his time from. So you have a chain that you're going to follow. ns.unc.edu is a Stratum 2 server using a unicast. So if we connect to him, that would make us a Stratum 3. Every 64 seconds, we ask him what time it is. And the counter has got to 14. It counts 0, 1, 2, 3, 4, 5, 6 as it counts up. So 64 minus 14 is how many seconds we have left. Reachability is funky, and we're going to look at it because it's funky. But it basically shows the last 8 updates. That's a byte. And if you get a 1 coming in that right end, that means that you had a good connection. I'm going to zip ahead. So 377 is what we're looking for. 377 means no zeros, and we have perfect reachability on this. Your delays mean different things at offset. How far away it is. It'll actually, you can write to a drift file to keep track of what your delay normally is. Anybody ever heard the term jitter? That's it. Jitter is a variation. Jitter gets to be a big thing when you're doing voice over IP. If you have a consistent delay, you can compensate for it, and it's not that big of a deal. If you have a 2-second delay, and then a 5-second delay, and then a half-second delay, and then a 3-second delay, and it jumps back and forth back like that, that's jitter, and that would drive you crazy on a telephone conversation. But right here, it's just going to make it harder to estimate your drift. Now, this NTPQ reachability field, here's what it's doing. I said it's a byte, and it's feeding from this right end. It's going to start off with all zeros, and every 64 seconds as it updates, it's recording in this whether it was a good update or whether it wasn't there for some reason. So it's going to start off with 1, and then go to 3, and go to 7. Now remember, it's an octal. There's your trick. Remember, octal is 3 bits. Counts to 7 and it starts over again. So 1, 3, 7 shows that these 3 are coming in. 1, 7, 3, 7. 2 plus 1 gives you 3, and then 4 plus 2 plus 1, 7. You eventually get to 377. Does that kind of make sense now? That's just a byte that you've separated into 3 hunks. And the thing that's funky about it is you don't have a third byte out here because it's just a third bit because it's just a byte. Now, if you manage to have something that looked like this, you've got some zeros in there. So then you have some reliability problems. But that's what that reachability does. And when you're watching this, you sit there and watch that reachability to see, okay, how long has it been going and how reliable is it? And if you want to know, you can say, If you've got 7 right there, you could say, well, that's 3 updates that it's gotten, and they're 64 seconds apart. Then you can say, well, it's been running for about 3 minutes. Time is the kind of thing that's going to take a little while to resolve. You don't just do it and boom, it's there. You can kind of, but if you're going to use the actual NTP protocol, it's going to take sometimes 10 minutes to get up and running and resolved and decide that it trusts its peers. NTP Stat tells you, I am synchronized, or it's not been long enough and I'm not synchronized. Synchronized means I have picked my NTP peer that I trust. This is the example that used the server from ECU that was a Stratum 2, and it has declared itself a Stratum 3. Time is correct within 161 milliseconds and is polling every 128 seconds. So about every 2 minutes it's polling. NTP Date, you can kind of use, aside from having the protocol continually monitor, you can just do a real quick, give me the date. So what I did right here was lie about the date. I said it was January 1st of 2000. Date set, boom. And that set my date to January 1st, 2000. The date command confirmed it. I said NTP Date and gave it a server name. And it went, it got it, it said it. When I said date again, it gave me the right time. So that's just a real quick way to set your date. We'll look at that more again in a little bit. NTP Trace. We are here. We're the Stratum 3. If we're wanting to look and see, well, what is the chain of command? What is my path back to the real live clock? How do we do that? Well, that's what you're doing. You're just playing the chain back to the primary source. And this is more just to kind of show you how it works than to make the NTP Trace command important, even though it's a neat little command. There's our NTPQ-P. And it has picked ntp.your.org. Look at its reference ID, CDMA, and look at what its stratum is. It's a Stratum 1. That indicates it is your primary, and these 2 with pluses are backups. They're candidates is what they're called. And we did note that it was a Stratum 1. If I say NTP Stat, and I wound up using these in conjunction a lot, I did NTPQ-P semicolon space NTP Stat. Just get these 2 commands over and over again. It tells me that I'm synchronized to 216.14.97.75. Now, to save you the trouble of wondering, if you did a host or NS lookup of ntpyour.org, that's its IP. And it is declaring itself, this machine is at Stratum 2 because it was at Stratum 1. Time's correct to within 58 milliseconds. And it is polling 256 seconds, just like it says. It will always pick the lowest delay as your primary. Again, Stratum is just how far you are from the clock. It doesn't necessarily tell you how reliable it is. Notice our reachability is all good. That's what it's synchronized to. Local machine considers itself to be Stratum 2. And it also considers itself to be synchronized. Then I run the NTP Trace, and it says I'm Stratum 2. This wound up being short. It went to NTP org Stratum 1 offset and gave me all this. It's a little bit neater if you wind up a Stratum 3 or a Stratum 4 and you can trace it. Entire chain will be shown to Stratum 1. Now, how do you set this up? You could have every computer on your local network run NTP and point to a server out there in the real world and try to clobber it. That just jacks up UDP traffic for, there's not a real reason. So, considering that a bad idea. A better idea would be to have your local server have a handful of NTP servers out there, find one it likes, have a couple of candidates, keep itself to within X number of milliseconds, then have your local guys all point to him for their time. So that way you have less traffic across your firewall and out to the world. Now these guys will synchronize to this guy pretty quick. How bad will it eat the resources up on this guy? Probably not too bad. It's UDP. They're tiny packets. And again, they're only hitting once every 64 seconds. So, a lot of them, but not a ton. If you have a big company and something big to deal with, you can have multiple NTP servers throughout your company, each of them pointing to a set of NTP servers out in the world, and then different local ones can point to them, and they can talk to each other to come to an agreement about what the actual time is. So that's a pretty complicated setup. Configuring it. Etsy ntp.conf, put in your pools of servers, whatever you want. Add your restriction. Restrict. One thing that's funny, this is mask, not netmask. If you're used to Linux, you may try to throw in netmask. No modify, no trap, no query. Like a Cisco command? Yeah. And again, this is for the server. If you want your local network to retrieve time, you can say, okay, allow my local guys, 24-bit, allow them to pull time off of me. No modify. I don't want any of these guys modifying my time if they happen to be very quick about things and malicious, or picked up a virus that tried to do it. Reject unknown servers. Restrict, default, ignore. There is your end of your filter that says don't let anybody else through. If you didn't want local guys pulling time off of you, if you were just a server and nobody looked at you, you could leave this out, do a restriction for your servers that you were pointing to, and then restrict, default, ignore. Don't let anybody else get anything off of you. Turn NTP on. Service NTP D start. That's your NTP daemon. CHK config NTP D on. And like I said, if you don't do anything, if you just turn it on, it works without tweaking it or anything. Configure NTP on a client. The simplest type of configuration. If you're just doing a workstation, you can use cron to run a job that sets it hourly, or sets it daily, or sets it when the machine's turned on. Something like that, so that you're not just sending UDP all the time for no real reason. In cron daily, you can just create the simplest little script and say user sbin nt date, boom, give it the server name and let it pull it. That will correct your time ever how often you want to do it. At that point, leave NTPD off. That's one less thing to run. One less hole in the wall. Now, if you are a client, if you're a server and you want to keep up with another server, if it makes sense, this is your email server and some other servers all trying to go together, you can add a single server. Again, the # is a comment. You drop in this single server, do a restriction for it to say just this one guy, and then reject anybody else. If you are just a server, if you are an email server and that's all you are, then you could say give me my time, reject anybody that tries to pull time off of me. Turn NTPD on. It can take several minutes to synchronize after startup. I've seen it synchronize really quick, and I've seen it take a long time. and it depends on your connection to the outside world. The best commands to check: NTP-Q-P shows your data, NTP stat shows your synchronization. That's what I'm doing right now. Just started it. 0 minutes. Notice there are no asterisks, no pluses, no anything over here. Look what my reachability is, 1. So we may be 64 seconds into it, according to the polling right here. The term polling, just like asking everybody something, it's just polling around. Okay. You get an idea of what the delay and the offset is. Notice the NTP stat returned unsynchronized. And it says that here's why it's unsynchronized and how long it's going to take to sort of get things up. After 2 minutes, it remains unsynchronized. But it's gathering time. Reachability, we've got 3 good reaches. Hit them 3 good times, and you can tell when I issued the command. Let's look at some of these guys. This guy's a stratum 1. This guy's a 2. This guy's a 2. Here's local. If it all falls apart, it can use itself, but it considers itself a stratum 10. It's got a real good delay, though, for a stratum 10, doesn't it? And it's measuring your delay. Now, what's the lowest delay on here? It looks like that tic-lax, whatever. Fiber. Some of these have funny names. But anyway, with just 3 good responses, it still doesn't trust it well enough to consider itself synchronized. Okay, after 5 minutes, we've got 3-7, which means we've got 3, 4, 5 good responses. And now it considers itself to be synchronized, and it did pick this guy off of its low delay time. It considers itself to be stratum 2, and correct, that's a monster time. It says I'm nearly a second off, or I can be nearly a second off. But things continue to crank. And these are candidates too. After 10 minutes, the big thing is notice what's happened. You got your full reachability. Time correct within 14 milliseconds. It won't always be that tight, but that's a pretty good time, isn't it? Boom. Well, that's it. That's NTP. Have any questions?